of an ideal fluid, the total energy means pressure energy, potential energy, as well as the kinetic energy per unit volume remains constant throughout the flow. So this was the equation that we have seen. P is the pressure energy, half rho v square is kinetic energy per unit volume, and rho gh, this is the potential energy per unit volume. So this whole remains constant. So any doubt from this Bernoulli's theorem?
No, ma'am.
Okay, see. Now next case in under Bernoulli's theorem only. See, the pipe that we considered for the derivation, this was at different levels. Both the ends were at different levels. This end 1 was at lower level and end 2 was at higher level. Means H1 and H2 are not equal. But just in case if it is a horizontal pipe, like this, the straight pipes that we have. So will the heights from both the ends, end 1 and end 2, be equal from the ground, or will they be unequal?
Equal.
Equal. So see, if height component is there on the left hand side as well as on the right hand side, means this is your equation rho gh. So this means P1 plus half rho 1 V1 square plus rho GH1 is equal to P2 plus half rho 2 V2 square plus rho 2 GH. This all remains constant. That's what is meant by constant. Now see rho GH. If it is rho GH on this side, left hand side, as well as it's rho GH on the other side. So won't this get cancelled, rho GH, if height is same?
Yes, ma'am.
Yes. So that's why only pressure energy and kinetic energy component will remain. So this will the equation that we'll be taking. This is the equation that we'll be taking. P1 plus half rho V1 square is constant. So that will be equal to only the height component will be getting cancelled. And height component getting cancelled means potential energy is constant, will be getting cancelled. And the pressure and velocity are inversely proportional to each other. So if pressure increases, velocity decreases. So just note this horizontal pipe case and try this question based on this one. Let me know what answer you're getting. Have you written the question?
Yes, ma'am.
Okay, see, let's discuss it. Let's say this is the pipe. The diameters are different. So this one is for the 3 centimeter, and let's say this one is for the 6 centimeter. So P1 is over here, A1 is the area, V1 is the velocity. Similarly, that we have taken while the derivation for Bernoulli. See, it's a horizontal pipe. So the difference in the height from the ground, that will be seen. So height will be equal. If h is the height, then h will be the height from this end as well. I have not drawn it equally. It would be a straight line from this point. Now see, according to Bernoulli's theorem and what we have just seen, if it's a horizontal pipe, then the formula for Bernoulli's theorem is this: P1 plus half rho V1 square. So if we write it for both the ends, for this end it would be P1 plus half rho V1 square. What will it be equal to? If this sum is constant, what will be equal to? P1 is the pressure for the first end, P2 is the pressure for the second end. This is N1, this is N2. See, it would be equal to P2 plus half rho V2 square. Clear?
Yes, ma'am.
All right, see, this sum of the pressure energy and kinetic energy per unit volume, this is constant. So you can equate it. Had there been a third part, then you would have equated it to third part, P3 plus half rho V3 square. So since the sum is constant, we can write it in this way. Now see P1, the first pressure that is given is 2 into 10 to the power 4. 2 into 10 to the power 4 Newton per meter square. That is Pascals, you can write it. Rho is the density of water. What is the density of water? Yes, Aisha. It's 1000 kg per meter cube. Density of water is 1000 kg per meter cube. All right. Density of water is 1000 kg per meter cube. In CGS, it's 1 gram per centimeter square. Now see V1, velocity for the first end, it is 4 meter per second. Now see, we have to find the speed and pressure for the second one. Means we have to find P2 and we have to find P2. Understood the question?
Yes, ma'am.
Now see what we'll do. First, let us put all the values that we have in the respective equation. So this will be equal to 2 into 10 to the power 4 plus half rho. What is rho? Rho is the density. What is the density given? Look, I've written all the data for you.
Density is 1000 kg
1000.
per.
Density is 1000 plus V1 square. So V1 is 4 meter per second square. So this will be 16 equal to P2. We are unaware. P2 is unknown to us. Plus half rho V square. Density is 1000 V2 square. So how many variables are there in this equation? P2 is unknown and V2 is unknown. Means the pressure for the second pipe and velocity for the second pipe, means the second end. That we are not aware of and we have to find it. That is the question asking from you. The P2 and the value of V2. Now see, let us first simplify this equation once. This will be equal to 2 into 10 to the power 4 plus this term will be equal to 8000 equal to P2 plus 500 V2 square. 1000 divided by 2 will give you 500. So this is the simplified equation that we have. Now, what is the equation of continuity? Do you remember the value we have done? What is the equation of continuity? Any idea? Or I'll repeat then, let me know. Yes, Aisha. A1 is the area for the first end. V1 is the velocity for the first end. A2 is the area for the second end, and V2 is the velocity for the second end.
AVT.
Exactly that AVT equation. So time is constant, time is same for both of them. So time will get constant. So on applying continuity equation, if T gets cancelled, so you will be left with AV is constant only. So that will be equal to A1 V1 is equal to A2 V2. So we have the diameters with us, so we can easily find out the area. So area will be equal to pi R1 square, pi R square. So instead of R1, we could write V1 pi 2 whole square. This is pi R square V1 equals to pi R square V2. Pi will get cancelled. This 4 2 square in the denominator. This will also get cancelled from both sides. So we'll be left with d1 square v1 is equal to d2 square v2. Now, what is the value of d1 given? d1 is 3 centimeters. This would be equal to 3 square. Velocity of the first one is given as 4. d2, diameter of the second pipe. What is the diameter of the second pipe given? Read the question.
6 centimeters.
6 centimeters. So this will be equal to 6 square multiplied by V2. So from here, we can easily find out the value of V2. V2 will be equal to 9 multiplied by 4 divided by 36. So this will give you 1. 9, 4, 4 divided by 4. So the velocity of the second pipe is 1 meter per second. So V2 we have got from the continuity equation. Now see, in this equation, only V2 is variable. The rest of the things are known to us. And P2, for finding out P2, we have to know the value of P2. Now we don't know the value of P2. V2 is 1. So let us put 1 in this equation. This will give us 28,000 actually, equals to P2 plus 500 into V2 square. V2 square is 1. 1 square is 1. So it will be equal to 500. So P2 will be equal to 27,500. Is the question clear to you?
Yes, ma'am.
Okay, so just note down the solution, and wherever you get stuck, you can ask me.
Done, ma'am.
All right, so that was about Bernoulli's theorem. Now let's discuss few applications of it. Now see, first application of Bernoulli's theorem is aerofoil lift. Aerofoil lift is the aeroplane wing that we have, is actually the aerofoil. So it is in this shape. This is the aerofoil, the aeroplane wing or aerofoil, you can say. Now, as I've told you previously in this section also, wherever there is high pressure, there will be low velocity. Wherever there will be high pressure, there will be low velocity. And pressure and velocity are inversely proportional to each other. And wherever there will be low pressure, there will be high velocity. So if this is the shape of the aerofoil, then these are the layers of the atmosphere surrounding it. So an aerofoil, or you can say an aircraft wing, is shaped so that air flows faster along the top surface than the lower one, as I've shown in this figure. So this is shown by the closeness of the streamlines above. These are the streamlines above the aerofoil compared to those at the lower side. Means you can see over here, the lines get closer to each other, but they are at a distance to each other in the lower surface. Now see, from the Bernoulli's theorem, the pressure of the air below is greater than the pressure above. So here it is high pressure, and here it is low pressure. This is according to Bernoulli's theorem. So it is this difference in pressure that provides us an upward force, that provides this, a net upward force to this aerofoil. This is known as dynamic lift. So actually Bernoulli's theorem is only one aspect of lift on the wing. Now see, if there is high pressure over here, the velocity will be high or low at the lower surface. If there is high pressure on the lower surface, will the velocity be high or low?
Hi.
No, it would be low. See, pressure and velocities are not directly proportional. The pressure is inversely proportional to velocity. Wherever there is high pressure, velocity will be low. Wherever there is low pressure, velocity will be high. Clear?
Yes, ma'am.
So if high pressure is over here, then velocity at the surface is low. And here the pressure is low, then the air has higher velocity. Now let's say this. Let's say P1 is the pressure, above pressure. And let's say the downwards pressure is P2. So P2 is greater than P1, means the bottom pressure is greater than the upwards pressure. That's why V2 will be less than V1, means the velocities will get reciprocal. The velocity for the lower surface, this is the lower surface of the aerofoil, this is the upper surface. So if you have to calculate net pressure upwards, that will be equal to P2 minus P1. That's how you calculate the difference. And if you have to find the net upwards force, so pressure is equal to force upon area. So if you have to find out the force, you can multiply pressure with area. So pressure difference multiplied by the area, this will give you the force. This is the net pressure, this is the force. Then the second application comes of the atomizer or spray. So similar devices are used to spray paint or those devices, insecticide. So what actually happens when the bulb in the atomizer is squeezed? The air rushes through the narrow neck of the atomizer. So this reduces the pressure in the narrow channel so that the atmospheric air pushes the perfume or whatever is the thing inside up the tube, leading to the narrow channel. So one application is atomizer or spray. Then the third application is blowing off roof in windstorm. when wind flows from high velocity above the roof of the house, above the roof of the house, then it causes a lowering of pressure above. When wind flows with a high velocity above the roof of a house, it causes a lowering of pressure above the roof. Now see, if the wind blows fast enough, then the internal air pressure can blow the roof off. So the net pressure will be still equal to this only. Whatever is the difference, P2 minus P1 multiplied by A will give you the force, and P2 minus P1 is the net pressure. Are the applications clear to you? Yes, Aisha? Am I audible to you?
Ma'am?
Yes, Aisha. Where were you?
No, ma'am. There was some problem, so that might.
Okay, so were you able to hear me? Have you understood this part? Application.
Ma'am, can you explain the second application?
Atomizer or spray, right?
Yes, ma'am.
Oh, yeah. The first one you have heard.
Yes, ma'am.
Okay, see. See the shape of the atomizer in this way. You must have seen those spray paints or insecticides. So these are of this kind of shape. Nozzle is there and a pipe is there. And this is connected and contains some fluid which evaporates and comes in the form of spray. From here only the spray comes. This is the rubber ball and there is passage of air over here. So let's say this is a perfume atomizer, for example. So when the bulb, this bulb of the atomizer is squeezed, then air rushes through this narrow neck of the atomizer. So what happens when the air rushes through this narrow neck? This reduces the pressure in the narrow channel at this point. The pressure over here, let's say this point, let's name this point A. Let's say this point is A. So this reduces the pressure in the narrow channel at this point A, so that the pressure pushes the perfume up. This perfume, what is actually the content, up the tube leading to this narrow channel. So then the perfume is dispersed into a fine spray of droplets. Here, this is how you must have seen this bulb is squeezed, and that's how the spray comes. So actually what happens when the bulb in the atomizer is squeezed, the air rushes through the narrow neck of the atomizer. This reduces the pressure over here. Let's say this narrow channel. So that atmospheric air pushes the perfume up the tube. Pushes the perfume up the tube means whatever is the liquid content downwards. So when it pushes the perfume or whatever where is the spray content up the tube leading to this channel, this is dispersed into fine droplets. That's what we desire. Understood now?
Yes, ma'am.
All right. So just note down these applications. Have you written it?
No, ma'am.
No. Okay. Just note down this. Then we'll do a question on this aerofoil.
Done, ma'am.
You've written the third point?
Yes, ma'am.
All right. So this is a question based on this only, the application one. Just note down the question and try to do it together. Just note it once. Just let me know when you've written the question. We'll do it together. Okay, let's discuss this. See, an aircraft has a mass of 3.3 into 10 to the power 5 kg. So let's just write down all the data that we have separately. So mass is 3.3 into 10 to the power 5 kg. This is the mass. Then the total wing area is 500 meters square. So area is given to you as 500 meters square. then it is in level flight with speed of 960 kilometers per hour. Velocity is 960 kilometers per hour. Now see, we have to find out in the first part the difference between the pressure. That is the same. Like if this is the body of the plane, then if P1 is the pressure applied, P2 is the pressure at the downwards end, then the pressure difference is actually P2 minus P1 that we have seen previously. We have to calculate this. So see, F is equal to P2 minus P1 multiplied by A. This is the formula that we have seen.
Yes, ma'am.
This one. This is the force. Now see, apart from this, one more force will also be acting, the weight of the plane in the downwards direction. So the force, the gravitational force, that is equal to mg. So this force and this force, both these forces are actually acting on the plane and they are equal. So we can equate them. P2 minus P1 multiplied by A equals to mg. From here, P2 minus P1 will be equal to mg divided by A. Now we just have to put in the values for them, and that's what we required, P2 minus P1. So mass was 3.3 into 10 to the power 5. Acceleration due to gravity is 10 and area is 500 meters square. So this is the difference in pressure. Clear? First part is clear. How have we
Yes,
calculated the
ma'am.
first part? Okay, now see the next part says fractional increase. Calculate fractional increase in speed of air on upper surface of the wing relative to the lower surface. Fractional increase in speed we have to find out now. Now see, for finding out the fractional increase, fractional increase is basically the change in velocity divided by the average velocity. Change in velocity means P1 minus P2 divided by the average velocity. Now see, velocity average is given to you, that is 960 kilometer per hour. And this difference in the velocity you have to find out. So let's convert 960 kilometer per hour into meter per second. For conversion of kilometer per hour, you have to multiply the whole number by 5 by 18. So 5 by 18, this will give us 800 by 3 meter per second. So we have the average velocity with us. Now see, on applying Bernoulli's theorem, on application of Bernoulli's theorem, P1 plus half rho V1 square. Now see, we don't have to write rho gh term because it has already mentioned in the question that the flight is in level flight. So it means it is in equilibrium. That is the height are equal. So rho gh will get cancelled. So we can simply write P2 plus half rho V2 square. Now see the difference in pressure from this. P1 minus P2 will be equal to, I have to transport this side over the right hand side. And if I take half rho common, I'll be left with V2 square minus V1 square. Is this clear? Is it clear till here?
Yes, ma'am.
Now see, A square minus B square identity. Do you remember how to open this identity? A square minus B square. This is equal to A plus B multiplied by A minus B. So similarly, if I apply this identity over here, P1 by P2, this is rho, this was half, this is half. This is half rho. So if I take this rho in downward side, 2 over this side, I'll be left with V2 square minus V1 square. On application of this identity, it will be V1 plus V2 multiplied by V2 minus V1. We have just opened this identity and have taken all the right hand terms on the left hand side. Now see, if I multiply and divide it by 2, will there be any change in? Can I multiply and divide by 2? So 2 and 2 will get cancelled. I'll be having the same equation that I was getting previously. So can I multiply 2 with 2?
Ma'am, you can cancel it also.
We can cancel. Yes, we will cancel. We can cancel this 2 by 2. You saying this?
Yes.
Yes, right. We will cancel this by 2. Now see, V1, this whole term that is left with us, this term, this is actually the average velocity. So V average is V1 plus V2 divided by 2. And we already have this value. Now see what all are left. V1 minus V2 is there, rho is there. This whole term is now average velocity. This is average velocity multiplied by V2 minus V1. Now see pressure difference we have calculated in the first part. Pressure difference came out this 3.3 into 10 to the power, let's say 6 divided by 500. This is 3.3 into 10 to the power 6 divided by 500. This whole term. Now the density. Okay, density is not mentioned. Oh, this side. See that we have to take the density of air and then this 1.2. So density is 1.2 for and then multiplied it with average velocity. Average velocity also we have converted 960 kilometers per hour into meter per second. That is 800 by 3 meter per second. So this is 800. 3 will go up. This whole term will give me V2 minus V1. So this is the difference in the velocity and this is the difference in the pressure. Clear?
Yes, ma'am.
Okay, so just note down the solution and wherever you feel you're not understanding, just ask me at that step. You have noted the question, right? Or
Yes,
do you
ma'am.
want to see the question also? Okay, fine.
Ma'am, can you scroll down? Done, ma'am.
All right, now let's see Torricelli's theorem. See, the speed, this theorem states that it's the difference in levels between the whole and the upper liquid is. Okay, let me draw the diagram. This Torricelli's theorem is also known as the law of efflux. Now understand what is written over here. If I take a vessel, I have taken a vessel over this side. And now what I do, I have just drawn an orifice from here. Means I have pinned it, I've inserted a needle or something, and I have drawn a hole over here. Now see, had I put liquid inside, let's say water or any liquid, will the water or that liquid go out from this orifice? Will any liquid go out?
Yes, ma'am.
Yes, of course, the liquid will move out through this orifice. If this is the pipe, this is the hole, then water will move out. Now let's say few parameters. This is the height above above liquid surface is small h. So let's say the small h is the height above the liquid surface from the hole. And let's say this whole complete liquid length, the length of the water column is y2. And the length of the liquid below the orifice, below the hole is y1. So let's say the velocity at this end, the second end, where the water is still there is no orifice, is v2. And v1 is the velocity at this first end from where this whole water is emerging. Now let's see. If I apply Bernoulli's theorem at both the ends, at end 1 and end 2 as well. So Bernoulli's theorem at ends 1 and 2. So yes, what is the Bernoulli's theorem? If you apply Bernoulli's theorem at end 1, if P1 is the pressure energy, then kinetic energy will be half rho V1 square. Now see here, the length are different, means the height of the water column is different. So you have to consider rho g h this time. Rho g h instead of h, you can have y1. So it would be rho g h because height won't get cancelled this time. Now the heights are different. Y1 is the height below the orifice. Y2 is the total length of water column. H is the height that is above the orifice. So P1 plus half rho V1 square plus rho g Y1 at this end 2. And for the Y2, for the second end, we have P2 plus half rho V2 square. Then the total height for the second end is Y2. This is rho g Y2. Is this statement clear?
Yes, ma'am.
All right. Now see. If I take all the values except for this term, let's see what we'll be getting. Half rho V1 square will be equal to P2 plus half rho V2 square plus rho g Y2 minus P1 minus rho g Y1. Yes, if I transport these terms on this side and keeping half rho V1 square on the left hand side. Now see, if I say again, V2 is the velocity for this end, A2 is the area, A1 is the area for this first end, and V1 is the velocity for the first end. Now if I apply continuity's equation, now can you tell me? We have just discussed this continuity's equation.
AVT.
AVT. AVT is constant since time is the same, so it will be A1 V1 equal to A2 multiplied by V2. Now see, for finding the value of V2 will be equal to A1 V1 divided by A2. And if you see, this area A2 is so much larger than this A1. What is A1? The A1 is the area of this orifice, and this is a very small hole. Like if you take those plastic bottles and you insert a needle in this, then the diameter of the hole will be so small. So that is the area for this orifice that you are getting. So it is very, very smaller than this A2, this comparative hole diameter of the vessel. So A2 will be very, very greater than A1. So A1, A2 and A1's ratio means A1 divided by A2. A1 divided by A2 will almost be equal to 0, because such a small quantity will be getting divided by such a big quantity. A2 is so much larger than this A1. So if A1 divided by A2 is approximately 0, means A1 divided by A2 is 0, then won't the velocity second be also be approximately equal to 0? Yes or no?
Yes, ma'am.
Yes. Now see, if this whole term is 0, so let us put this V2's value in this equation. So that finally we can get rid of this half rho V2. Now see, if we put V2 separately, so we'll be left with half rho V1 square equals to P2 minus P1 can be put together now, plus rho G, and Y2 can be put together. Y2 minus Y1 can be put together. Now see what I have done. I have just written this equation, the same equation. I have just taken P2 minus P1 together, and I have taken rho G common. This is Y2 minus Y1. And this term is now equal to 0. Now this term is equal to 0. Why is it equal to 0? Because the second velocity is equal to 0. Clear?
Yes,
What
ma'am.
I've written? Okay. Now see, just we have to simplify this equation so as to get the result. V1 square is equal to, if I take 2 and rho over that side, this would be 2 by rho P2 minus P1 plus rho G, again 2 divided by rho will be multiplied by this term also. So Y2 minus Y1 divided by rho multiplied by 2. This term, normal distributive property. Like if rho and G, 2 divided by rho will be multiplied by this term as well as this term. So I have written both these. 2 by rho over this side and 2 by rho on this side as well. So rho will get cancelled. Now see what are we left with. If you take V1 and just V1, so the square will become under root. This will be equal to 2 by rho P2 minus P1 plus 2G Y2 minus Y1. This whole term under this root. Now see Y2 minus Y1. What actually is Y2 minus Y1? Let us see. Y2 is the length of the water column. Y1 is the length of the water column below the orifice. So according to the figure, according to you, for both of you, Akifa, you can also see from this figure. What is Y2 minus Y1? Anyone?
H.
H, exactly. Y2 minus Y1 will be equal to H only. So we can put the value. This 2G instead of 2, you can put Y2 minus Y1 equal to H. This will be equal to 2 by rho P2 minus P1 plus 2GH. Now see, if the pipe is open, if both ends 1 and 2 are open to atmosphere, So this is the formula. V1 is equal to 2 by rho P2 minus P1 plus rho G. But see, if both are open to atmosphere, means this is also open to the atmosphere and this is also open to the atmosphere. So will the pressure at both these ends be equal to the atmospheric pressure or not? If these are open to the atmosphere, both these ends, will the pressure at both the ends be equal to the atmospheric pressure or not?
Yes.
Yes. So see, P2 and P1 will be same. That is the atmospheric pressure. If P2 and P1 are same, means this whole term, the difference will be zero if both the terms are like terms. So see, V1 will be equal to, this whole term will get cancelled if P1 and P2 are equal. This will be P naught minus P naught, that is zero. So only under root 2gh will be left. And this is what is known as the Torricelli's theorem. So this theorem says that if the difference in the levels between the hole and the upper liquid surface in a drum or a vessel is h, small h, then the velocity with which the liquid emerges from the hole is under root 2gh. Velocity is under root 2gh. This is the derivation for it. Is the Torricelli's theorem clear?
Yes, ma'am.
Okay, so write down it, then we'll do some questions on it.
Done, ma'am.
Done.
Both of you, Aisha, you've also written.
Yes, ma'am.
Okay, let's discuss a question on this topic. See, a drum of radius 30 centimeter radius has capacity of 220 decimeter cube of water. Now it contains 198 decimeter cube of water and is placed on solid block of exactly the same size as of drum. Now you can see it is from the figure. This is the block and this is the similar size drum placed on it with water filled inside. Now see, it says that if a small hole is made at the lower end of the drum, perpendicular to its length, in this way, this part, a hole has been drawn in. Now, what is the velocity of water that will flow from this hole? And what will be the range of water? See, for the first part, we have the simple equation. V is equal to under root 2gh. So, velocity will be equal to 2 multiplied by g. Now, see for g and h. See, okay, see first we need to understand this. Radius of the drum is 30 centimeter. Its volume is given to us 220 centimeter, 220 decimeter cube. Now see, it contains 198 decimeter cube of water placed on it. Means this blue colored part is containing 198 decimeter cube of water. Now see, for finding out the velocity, we have to find out the height first because height is not mentioned. G will be, we know the value, G is a constant and H is still unknown to us. So see, for finding out the height will be this height. For finding out the height, we need to find the length. If I say L is the length of the container, if I say L is the length of the container, the volume of the container will be equal to, what is the volume of a cylinder? Pi r square L. So pi r square L. This is the volume. And this volume of the container is actually given to us, 220 decimeter cube. So we can simply equate this 220 centimeter cube, 10 to the power 3, to convert it into centimeter cube. This was 220 decimeter cube. We have converted into centimeter cube is equal to pi r square. Radius is given to us as 30 centimeters. So 30 square multiplied by the length. From here, see, 220 into 10 to the power 3 divided by pi 30 square. This will give us the length. Now see, length on solving this one, try this after the class. Once you will solve this whole term will come out to be approximately 700 divided by 9 centimeters. This is the length. Length means length of the block. This is the length of the block. So L we have. Now for the height, because we also have to find the height for calculation of the velocity. Now see, height is this part. This part means you have, if you find out the volume of this portion that is mentioned to you, volume of this portion, the blue portion, that will also be equal to volume of water will also be equal to pi r square L. That's how we calculate the area. Volume means area multiplied by the length, area multiplied by the height. So volume of water will also be equal to pi r square L, and volume of water is also given to you as 198 decimeter cube. So if you convert it into centimeter cubes, this will be equal to pi r square. Again, r we have as 30 square multiplied by the h. Height over here is the h. So on solving this, you will get height approximately equal to 70 centimeters. Now you solve the first part. Now we already have the values. Since centimeters and all these units have been, so let us take acceleration due to gravity as 980 centimeter per second square, because 9.8 meter per second square will be the SI unit. So G is 980 centimeter per second square. Height is 70 centimeters. We have seen how we have calculated it. So this is the velocity. So first part, is the first part clear? How is the velocity of water from the whole calculated?
Yes, ma'am.
Okay. Now see range of water. If you remember your chapter 3rd, projectile motion, there you must have encountered this topic, range, time, horizontal projection. So this is similar to it if you recall it. This is how the trajectory of the projectile was recorded for horizontal projection. So if you have to calculate the range of water, this means this part. This is the range of water. This is how we used to calculate it in projectile motion. If this is the trajectory of the particle, then this is the range. This was the height. So we have to find out the range of water. So see, for finding out the range of water, you have to relate it to projectile motion equation. U is equal to under root 2h divided by g. Here h will be the length of the vessel. Okay, let me not write it as h. I'll write it as length only. To L by G. L is actually the h. So I hope you remember this formula. U multiplied by 2h by G. Ut, this has been derived from the similar equation. Ut. Instead of T, we have written 2h by G. Now see, length will be taken of the block now. Length of the block. Because this is the height that we take. For the projectile motion, this is the height that we take. And what is the height for this? This is the length of the block. If I say h dash is the height, then h dash is equal to length of the block. Now see, you have all the data with you again. R range is equal to u, or velocity is this that we have calculated for the first part. That is under root 2 into 980 multiplied by 70. This is u, the velocity that you have calculated for the first part. Under root 2 multiplied by length. See, length is this length that we have seen. This length, 700 by 9 divided by g. G is again 980 centimeters. square. So on solving this equation, you should get the answer roughly equal to 147 centimeters. So is it clear how have we calculated the range of the motion of the water's fall?
Yes.
Both the parts clear to both of you?
Yes, ma'am.
All right. Just note down the question as well as the solution, and wherever you get stuck, you can ask me.
Ma'am, can you scroll down?